So this is what I would call a level 1 empirical problem. There is a level 2 and it involves an extra step, but we're just going to do the straightforward problems to begin with. So the great thing about percent is that you can make little assumptions about them. This is kind of a thing that happens in chemistry more than once. It's not like I'm going to take 100 grams of something and go put it in an instrument and like most of the time when you put something in an instrument, like it's gone. So it's not like I'm going to throw away 100 pounds. This is like a little piece of paper, that's like 100 grams. It's quite a bit. That's probably, depending on what you're making it, that's like a big palms full or a lot more even. And, put it in some kind of instrument and just lose it. But it's more likely I put like a gram or half a gram or 0.25 grams or just a very small amount. But if you remember, you learned that if you've got something that's pure, it's only got one thing in it. If you put a big sample in or a little sample in, remember that ratio of atoms? It's the same. So like if it's a 1 to 1 to 1 ratio, it doesn't matter if it's a big thing, 100 grams, or if it's something small, it's still 1 to 1. So assuming that what you've got is pure, it's okay if you want to make the math easy and assume 100 grams. So you might be thinking, well, how does this make the math easy? Well, what it does is it means that if you have, like you put in the instrument and it comes out and it says that it's a 38.43% is Mn, and if you know that you have 100 gram of sample, remember to figure out how many grams are Mn. You just take your percent divided by 100% times however much, this would be my total sample. And you'll notice my hundreds cancel and my percents cancel. And you'll notice that I just end up with 38.43 grams. So it's like a really easy way to basically take the percentages that are in the problem, and I have these written along the side here, and just turn them into a gram, and a gram. It's like a really easy way to do that. Now, what you want to do in this problem is you want to find out what are the numbers over here. So as you see, I've got some numbers that are missing. I don't know what that is, I don't know what that is, and I don't know what that is. That's what I'm trying to figure out. So that's why I have one for Mn, one for C, and one for O. I need each of their moles. And you're going to remember something, that those are normally numbers like 1, 2, 3, 12, 14. They're like numbers, they are not decimals. And that's an important little note to note when we're doing these. So I'm going to go ahead and do my conversion here. What I need is not grams. What I really need is moles. So grams of Mn into moles of Mn. Grams of carbon into moles of carbon. Grams of oxygen into moles of oxygen. I'm going to zoom in on Mn, and you'll notice its molar mass is 54.94 grams in 1 mole. And then carbon is 12.01 grams in 1 mole, and oxygen is 16 grams in 1 mole. I'm going to bring my calculator over. That's going to give me 0.699. Now, with these, you really want to put an extra decimal place in. 49 moles of Mn. And then .3988. That's an extra decimal place in. And then, make that a little smaller, 44.77 divided by 16.00. And that gives me 2.79812. And that's moles of oxygen. I gave an extra sig fig, but here's the deal. You can't write Mn 0.69949, carbon 1.3988, and oxygen 2.7981, and clearly see the ratios. It's just numbers. And one of the rules with these formulas is that you have to write them as whole numbers, because we're assuming one quantity of it, like we're assuming full atoms or full moles. So the math trick to make those become actual numbers is that we're going to divide by the smallest. So divide, I'm actually going to write it right here, divide by smallest. You'll notice this top one is the smallest one in those three cases. So 0.69949 moles of Mn. This one's great because you can go ahead and solve it right then. And then 0.69949 moles of Mn. And I usually will go ahead and write them all in so I don't forget which one I'm dividing by. I happen to have this one already in my calculator, so I'm going ahead and do that one. 0.69949. That one comes out to be 4 moles of O. 1.3988 divided by 0.69949. And that comes out to be 1.999. And hopefully you're seeing how close that is to 2 moles of carbon. So my final answer is MnC2O4.